Hello students, so now we are starting with our next chapter, that is current electricity. Chapter is discussion of JEE Mains 2025 January attempt. Let's start with our first question. So first question, we have two statements. So let's see what is first statement. The equivalent EMF of two non-ideal batteries connected in parallel is smaller than either of the two EMFs. So first of all, you calculate the equivalent EMF. What is the formula of equivalent EMF? E1 R1 plus E2 R2 divided by R1 plus R2, right? You have to check that this is smaller than E1 and E2 both or not, okay? So for the time being, take a case that R1 is equals to R2, okay? Just to check, okay? Because this is also one possibility. So if we check, then what we got, E1 plus E2 divided by 2, right? So this is what? In middle, right? So not smaller than both of them. So I can say this is wrong. So statement 1 is wrong. Then he is saying statement 2, the equivalent internal resistance of two non-ideal batteries connected in parallel is smaller than the internal resistance of either of the two batteries. See, what he is saying is that R equivalent R1 R2 divided by R1 plus R2, this is smaller than R1 and R2 both. Okay, this we have to check. So how to check? Just see here. We can write the R equivalent as R1 plus R2 multiplied by R2 like this, right? So if I see this quantity multiply by R2, a quantity less than 1, right? So this quantity is less than R2, right? Because I multiplied a quantity which is less than 1 into R2, right? So this will be less than R2. Similarly, I can check for the R2 also. So R2, write down it like this, R1. Okay, so R1 multiplied by a quantity less than 1, right? So this will be less than R1. So I can say R equivalent is less than R1 and R2 both, right? So statement 2 is true. That only he is saying if you read clearly. So I can say statement 1 is false, statement 2 is true. So second option answer. Now let's go for the next question. So next question, you can read the question. So if you see here, it is in the middle, right? So we can say half of 0.5, 0.5, right? So if you draw the circuit, in this case, you can read the question, okay? By your own. Pause the video and you can read. So here battery is given as 0.9 volt, okay? 0.9, right? 0.9 volt, and then he's saying here 0.5, and then here also 0.5 ohm, and then here 2 ohm resistance. Like this circuit will come, okay? These two are in parallel. So parallel, what we can see, 0.5 into 2 divided by 0.5 plus 2, right? So this will come how much? 1 by, this is 2, 5 by 2, right? So this will come 2 by 5, means 0.4, right? How much came? 0.4. So I can say here we have resistance 0.4 ohm, right? 0.4 plus 0.5, 0.9. So equivalent resistance came 0.9. Okay. So V equals to IR. We can say, so V is how much? 0.9 equals to I into R is also 0.9. So I came how much? 1. So this is 1 ampere. So we have a 1 ampere. So fourth option is your answer. Okay. Now let's go for the next. Easy question, right? Now let's go for the next question. Third question, he is asking resistivity versus temperature. Okay. So resistivity versus temperature, linear curve, right? We know already we have the equation of this curve. So by that you can answer directly fourth option. From the notes, equation is in the notes, right? Now let's go for the next fourth question. See. So fourth question is asking net current flowing in the given circuit is. Okay. So by look, it is looking very complex circuit, right? How this capacitor we will solve. Okay. But see, one catch is here. You have to see. When this circuit is after enough long time, we can say that this will break. From here current will not flow, right? So from here current will not flow. So this is broken here. Okay. Now if you see this point, from this point only, this is everything of this circuit is coming to this point only, right? And there is no other battery in this circuit, right? This side circuit. So I can say here this also got disconnected. Why? Because this is coming to one point only, right? Okay, so there is no battery, so nothing will flow. Understood? Now here for this resistance, this side is open, right? Because here no current flow, right? This side is open, so this side, one side only connected, right? So this resistance will also not work. Okay, so what you have is all, you have 2 watt battery. So let's draw this. you have what is remaining there. A 2 watt battery is remaining. Okay, and then after here 2 ohm, 3, 4, 2, 3, 4. Okay, so here we have 2 ohm resistance, then we have here 3 ohm, and then we have here 4 ohm. Okay, and downside we have nothing. Okay, here we have directly connected, and then we have remaining 6 ohm, right? So we have 6 ohms like this. Okay, 6 ohm. Okay, so this is our remaining circuit. Now if you see this, between this point and this is 1 point only, right? So 6 ohm and 3 ohm are in what connection? Or we can say parallel connection, right? So parallel connection, how much you will get? 6 and 3, so you can say 6 into 3 by 6 plus 3. So how much is this? 2, right? So I can say here it will come 2 ohm resistance, right? 2 plus 2 in series, right? So 2 plus 2, 4. So this came 4. Hold on. This came 4. This is 4 ohm resistance. That's it. So we can say then this is 4 ohm. Okay. Now 4 ohm and 4 ohm, between these 2 points, these are in parallel, right? So 4 ohm parallel means how much will come? 2. How much it will come? 2 ohm. So this is 2 ohm. Okay. Now 2 watt battery and 2 ohm resistance, V equals to IR. That's it. So V is how much? 2. I, you have to find out R is 2. So I is equals to 1. That's it. See, by look, it is looking complex, but it is answer is 1 ampere. That's it. Okay. Here it got disconnected, right, because of capacitor. So this circuit, no battery, coming to the 1 point only. That's why it got disconnected, right? So it will no current flow in this direction, right? And for this resistance, there is one end is open and one end is closed. So this will also not work. So this is also cut off. Now you have simple, easy, very easy circuit which we can solve easily. So just see the question by patience, little bit. By look, it will look difficult, but there is a possibility that it is very easy, right? Okay. Next, this is fifth question. So fifth is saying a galvanometer having a coil of resistance 30 ohm, 20 milliampere of current of full scale deflection. If a maximum current of 3 ampere is to be measured using this galvanometer, the resistance of the shunt to be added to the galvanometer should be. Okay. So first understand how galvanometer. So in galvanometer, if we see, we have in the galvanometer we have a resistance, right? Okay, this is, you can say RG. Let's name it RG. Okay, and then we have a shunt resistance, right? Like this. So RS. This RS you have to calculate. Now he is saying through this the current is 20 milliampere, right? So this is IG, let's mention. So this will be I from coming from here. If you see from the notes, this is how we write down, okay, in general. Okay, so from here, how much it will go? If this is I is coming, IG is going this side. So how much it will go this side? I minus IG, right? Through this resistance. Now between these 2 points, I can say this is between the same potential. This is also same potential. So equate the potential. IR. So I minus IG into RS is equals to IG into RG. Okay, that's it. Now put the value. Here. What we can say that I minus IG. So you have all the values. I is how much? 3 ampere, right? And this is 20 milliampere. Okay. So 3 minus 20 milliampere. So if you see, this is 0.02, right? 10 to the power minus 3 will come. Okay. 1, 2, 3. Correct. Into RS you have to calculate is equals to IG. IG is given 3, 0.02. Okay. Into RG is given 30, right? Let's check. Yes, 30 ohm. Okay. So this is what equation is. So from here RS, if we calculate, so how much is coming? 0.02 into 30 divided by this is how much? 2.98. 2.98. Now this RS he is saying is equals to 30 by x. Okay, and you have to get this is, he is saying this is 30 by x. To find out the x, so 30 got cancel out, and we have x is equals to point you can remove 298 by 2. So this is 149. X is equals to 149. Okay, so X 149, second option. Okay, next sixth question. So sixth, now seventh question. Okay, sixth question we had a problem with it, so we moved it, or we send it to other chapter because we have mismatch here. Okay, seventh question. A wire of resistance 9 ohm is bent to form an equilateral triangle. Then the equivalent resistance across any two vertices will be. Okay. So sixth question we removed basically because it carries some other concept also, right? So we move it to next chapters so that you don't get confused anything. See what he's saying. Triangle you formed. Okay, this marker is getting bigger and bigger. Okay. So what we are saying is, in triangular form, if you take right length, then what we can say, then resistance 3 ohm, here 3 ohm, and here also 3 ohm. Like this it will come. Total is given 9 ohm, right? For total length. So this will be 333 equilateral triangle, right? Okay. Now what he is asking is, between these two points, what is the equivalent resistance? So I can say this is in series. So I can say 3 plus 3 is 6. So this will be get that directly got 6, right? 6 ohm. Now 6 and 3 are in parallel. So directly 6 into 3 divided by 6 plus 3, this came 2, right? So equivalent resistance is 2 ohm. So your answer is 2 ohm. Okay. Now next question. Eighth. So eighth we have a wire of resistance R is bent into equilateral. Now if you see this question and the previous question is little bit same only, right? So this is 24 gen shift 1 and this is 28 gen shift 1, right? So now see, he's checking the same concept only. What he's saying, a wire of resistance R is bent into an equilateral triangle and an identical wire is bent into a square. The ratio of the resistance between the two end points of an edge of a triangle to that of a square. Okay. See here, what he is saying, that R resistance you bend in a triangular form, right? So what will come? R by 3, R by 3, R by 3, right? In between these 2 points, resistance you have to calculate. And for the square, if you do the same thing, then what you can say, total is R, right? This is R by 4, R by 4, R by 4, and this is R by 4. Okay, and you are calculating resistance around this point. Okay, now see, if I calculate R equivalent here, this R by 3, R by 3, how much in series, right? So how much this came? 2 R by 3. Okay, and then 2 R by 3, R by 3 are in parallel. So what can I say? 2 R by 3 into R by 3 divided by 2, this sum will come R only, right? So this will come 2 R by 9. Okay. In case of a square, if I see, this all three are in series, so directly add. So how much came? 3 R by 4. This came 3 R by 4, right? 3 R by 4 and R by 4 are in parallel. So R equivalent is equals to 3 R by 4 multiplied by R by 4 divided by sum R only, right? So this came 3 R by 16. Okay. Now ratio is asking triangle to square or square to triangle to square. So triangle, that is 2 R by 9 and divide by 3 R by 16. So multiply by 16 by 3 R. Okay. R got cancelled out. This 3, this is 16, 28 by 27. 32, sorry. 32, no? 32 by 27. Okay. So 32 by 27. 32 by 27, third option. Okay. Okay. Next, ninth. Okay. Now this kind of questions easy to solve. In the notes we have solved many questions. See how. We say we have to find out what equivalent resistance, right, between this point and this point. So let's name this point as A. Okay. And let's name this point as B. Okay. Understood? Now we have to check that when we are drawing the circuit, okay, when we are drawing the circuit, we will keep this side A point and this side B point. Okay. Now wherever the in between there is other potential point also, we will mention that and we will connect between them a resistance, whatever the resistance which are given to here, right? So if I check here between these 2 points, so I can say this is B point. There is nothing in this wire, right? And this is also, so this is also B point, right? Here directly wire connected, so this is also A point only, right? So I can say R by 3 is connected between A and B. Here also R by 3, this R by 3 is also connected between A and B, and this R by 3 is also connected between A and B. Okay, so what can I say? Here all three resistance are between this only, A and B only. So this is like this. This is how we simplify. Okay, so here R equivalent, all are in parallel. So I can say 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus 1 by R2. So this will come 3 by R multiply by 3, because 3 times you have to write down. So this came R equivalent is how much? R by 9. R by 9. So R by 9 is your answer, first option. Okay, this is how we solve. Even if there are many complex circuit also have solved in the notes. Okay, this is just a very simple question. Next, 10th he is saying the value of current I in the electrical circuit as given below when the potential at A is equal to potential at B. So potential at A and potential at B is equal, means through this 30 ohm resistance nothing, the current is not flowing, right? So what we can say, this is Wheatstone bridge, right? So this is Wheatstone bridge, means what is the condition? 10 by R is equals to 20 by 40. Everything is derived in the notes, right? So I can say 10 by R is equals to 20 by 40. So from here R will come how much? 20. R came 20. Now we have to, what we have to find out? We have to find out the current. So this came 20. Now current, okay. So this nothing, the current is not flowing through 30 ohm, right? So we can remove this 10 plus 20, 30, and here 20 plus 40. So this is how much? 60. So let's draw the circuit. So circuit is saying this side, and then you have 20 plus 10, that is 30 ohm, okay, and this side you have how much? 40 plus 20, 60 ohm, okay, and then you have a battery. So battery is 40 watt, okay, 40 volt, okay. So this came how much? This is in parallel. So just write down 30 into 60 divided by 30 plus 60, 90, 0 got cancelled out, 3, 2, 20 ohm, right? So here it will come 20 ohm. Understood? Now V equals to IR, so 40 is equals to I into 20. So I is equals to 20 ampere. Sorry, 2 ampere. What 20? 2 ampere. Okay. Understood? So answer is your 2 ampere. 10th question, 2 ampere. So by Wheatstone bridge you can solve, right? Next, 11th question. The difference of temperature in a material can convert heat energy into electrical energy. To harvest heat energy, the material should have. Now see, what he is saying is basically from the difference between the temperature, okay, there is a flow of electrons, right? By which we can generate the heat energy, the electrical energy, because there is a flow of electron, right? So for that, what should be the condition between the thermal conductivity and electrical conductivity? See, when I have temperature difference between 2 points, right? Okay, so I want the temperature difference, right? So I don't want the heat flow, okay, I don't want the heat flow, because the temperature difference will be maintained, then this electron will flow, right? So if the temperature difference came equal, then there is no need, right? There is no flow of the current, right? So I want the temperature difference, so my thermal conductivity should be low, the heat current should not flow, heat should not flow, right? So for that, thermal conductivity should be low, but I want the current to flow, right? So my electrical conductivity should be high, okay, because I want to maintain the temperature difference, so my thermal conductivity should be low, right? The heat should not flow, but I want the electricity to flow, right? That only I am generating, right? So my electricity will flow when my electric conductivity will be high. So what can I say? Low thermal conductivity and high electric conductivity. So my answer is 4th option. Understood? So this is about this chapter. Thank you.